Welcome to the Getting Started with Windows Azure video. Windows Azure consists of a set of independent services that help you create secure, reliable, highly available, and scalable applications and services. To me, Windows Azure is really a branding term, and it consists of a bunch of independent services that you can pick and choose to help you build your overall solution. Now, the good thing about each of these services being independent from one another is that you get to pick the ones that you want to use. You're not in for a penny, in for a pound. If you want to use the compute service, you can. If you don't want to use the data service, then you don't have to. And this also allows you to build hybrid applications where some of your application is running, let's say, on premises in your own data center, but some of your application is perhaps running up in a Windows Azure data center. Now that's the good news. The bad news is that each of the Azure services has its own pricing model. And so figuring out what it's going to cost you if you use, service A and service B and service C and try to figure out how that's going to cost, that can be a little bit challenging. Also today, each of the services has its own service level agreement too, and the services also have different ways of authenticating with each other. So this can make it a little challenge for a software development shop to remember, well, for this one I use a certificate, but for this one I use a username and password to do its authentication. Now, Windows Azure Platform Services consists of many services, but there are two services in particular that are kind of the bread and butter of Windows Azure. There's the storage services, which is a way for you to take your data and have it hosted in a Microsoft data center. And then there's also the execution services, which is your code that's now executing in a Microsoft data center. Now, Windows Azure consists of many other services too, such as a networking service, otherwise known as virtual network, and there's also a connect service. There's a caching service. There's a messaging service known as Service Bus. There's an identity service known as Windows Azure Active Directory, and so on. And of course, over time, Microsoft will be introducing more and more services into their plethora of services under the Azure umbrella, if you will. Now, Microsoft has 8 data centers today where they host Windows Azure. And 4 of these data centers are in the United States, and 2 of them are in Europe, and 2 of them are in Asia. And when you are deciding whether you want to put your data or code into one of these data centers, you choose which one of these data centers is interesting to you. And of course, you can choose multiple. In fact, there are a lot of companies that put information about their European customers in a European data center, information about the United States customers in a US data center, and so on. And you can certainly, have different pieces of your application running in these different data centers. But if that's something you choose to do, then that is entirely up to you. You can't just go to Windows Azure and say, please deploy this globally, and then your code and or data get distributed automatically across the globe. You choose exactly which data centers you want your code and or data to be executing in. Now, there are 3 ways to execute code in Windows Azure. The first way is using what's known as Windows Azure Virtual Machines. When you are using the Windows Azure Virtual Machine mechanism, basically what you do is at your machine sitting at your desktop, you go and create a virtual hard drive image. On that virtual hard drive image, you can install whatever operating system you want. So if you want Windows, that works fine. If you want Linux or some other OS, that's all fine. You also install any other components that you want on that virtual hard disk, and then of course you install your application as well on that. Then ultimately what you'll do is you'll take that VHD image that has all that information on it, and you can go and upload that into Windows Azure. They can then create in the data center virtual machines that are running on their physical machines. They will mount your virtual hard drive, then boot into whatever operating system you chose, and then run whatever application code you want. This is frequently referred to as infrastructure as a service because you are paying for the infrastructure. That is, you're paying for the electricity from Windows Azure, you're paying for the hardware machines, you're paying for the network, but you are providing your own platform, your own VHD with your own operating system, application, and components on it. That also means that you manage these VMs that have your VHD contents. So if an upgrade comes out to the operating system you're using, or a security patch, or you have a bug fix that you want to make to your application code, then you go and apply those to this VHD. Again, you upload the new version of the VHD into Windows Azure, and then it can bring down existing VMs that are running the old VHD and bring up new VMs running the new VHD. And now the new version of your code is running, but you manage all of that yourself. As I say here, any operating system is supported. You install whatever operating system you want into the virtual hard drive. And when you deploy your VHD into Azure, you can tell it how many virtual machines you want running that VHD code. And of course, you would pick one or more machines if you want to be able to scale out to handle a larger load. Now, another way to execute code in Azure is using what's called Windows Azure websites. With Windows Azure websites, you must be building an application that runs on our Internet Information Server. That is, Microsoft's IIS will be the web server that's installed on these machines. So you have to build an app that integrates in with IIS. You simply manage the app itself. So if you have a new version of your code, you would simply deploy that to Windows Azure websites. Today, as I record this, all Windows Azure websites are running on top of Windows Server 2008 R2 that has IIS 7.5 installed and the .NET Framework 4.5 installed. But in the future, Microsoft will, of course, put Windows Server 2012 on and IIS version 8. And Microsoft controls this. So whenever they decide to roll out a new version of the operating system or patches, all websites get upgraded to the latest version. When you are building a website application with Windows Azure, you yourself do not have any control over which operating system, which version of IIS, or which version of the .NET Framework. For the virtual machines here, your code is shared. That is, within a single virtual machine, that VM could be running code from your website and another company's website and another company's website, all running inside the same VM. The main benefit of Windows Azure websites is that it is very economical. In fact, every account on Azure gets to deploy 10 websites for free. Because it is free, there is no service level agreement associated with it, and you don't really have any guarantees about the performance of your application. The last way to run code in Azure is to use what's known as a Windows Azure Cloud Service. This is otherwise known as the Platform as a Service architecture, and this is what Microsoft is really promoting and hoping that most companies will eventually migrate to. With the cloud service, you can deploy a Windows app or an IIS app. So in other words, any application that runs on top of Windows would work here. And if you want, the Windows can have IIS on it, and then you can build an application that runs in IIS. But if you would rather use a different web server and not use IIS at all, as long as it's a web server that was built for Windows operating system, you can deploy that other web server into these virtual machines. Any application that runs on Windows can be deployed into the cloud service. Now you manage your application or your IIS app, whatever it is that you have deployed. Today, the Windows Azure Cloud Services supports Windows Server 2008 and Windows Server 2012. And so you can choose which one of these operating systems you want put onto the virtual machines that you're running. But this is a platform as a service architecture, as I said. And so what that means is, as new versions of the operating system come out, either due to patches or security fixes, then those patches and security fixes get applied to the virtual machine automatically. So you simply have to worry about your Windows application or your IIS app. You don't worry about the operating system or IIS itself or the .NET Framework itself. And as new versions of those come out, Microsoft will automatically bring down your virtual machines, apply whatever security patches, and bring your machines back up. And this ensures that your application is always running on the latest, greatest version of the operating system. Now, I will say that some people are a little nervous about this, and so it is possible to opt out. And if you would like to, you can, when you create your application, say to Azure that you wish to opt out of operating system and security patch upgrades that are coming out, in which case you would have to control that yourself. And as for the number of virtual machines you have, it's one or more. So you would deploy your application out to the cloud service and you configure Azure to say how many virtual machines you want running your code. And it can be one, or of course, if you have a large set of customers that will be hitting you simultaneously, then you can go and scale that out so that you can handle the load that's being passed in. Now, on this slide here, I talk a little bit about the architecture of how this actually works inside the Windows Azure Data Center machines. What I show here is a big rectangle, which is a single physical machine. And of course, the data center is loaded with physical machines. When that physical machine boots up, it boots up into the Windows Server hypervisor. And the hypervisor goes and creates this host operating system here, and inside the host operating system is this host agent. The host agent is code that was written by the Windows Azure team at Microsoft, and it responds to incoming requests that are coming into the box. Windows Azure has this thing called a fabric controller, which periodically sends heartbeat messages out to various machines that are inside the data center, making sure that those machines respond. And if those machines respond, then Azure believes that the machines are physically healthy and everything's running fine. If the machines don't respond for some reason, it could be that a network cable was cut, or maybe a network controller has gone bad, or the machine for whatever reason has turned itself off, then the fabric controller will detect that, and it will go and provision other machines, and then whatever companies' websites or code were running on the physical machine that's no longer responding, Azure will automatically provision new physical machines and get the company's applications running on the new physical machines. This detection and redeployment usually happens in the order of just a few minutes. Now, we talked about the cloud service. If you deploy your application as a Windows Azure cloud service, then Windows Azure will go and create one or more virtual machines for your cloud service. And just for the record, Windows Azure will usually deploy the different VMs onto different physical machines so that there is no single point of failure. If all your virtual machines were deployed on a single physical machine, and if that physical machine had a hardware failure, then all of your virtual machines would stop running and stop responding to client requests that are coming in. So Azure by default will automatically move your virtual machines onto different physical machines to make sure there's no single point of failure. When your cloud service virtual machine does come up on a physical machine, Azure is going to take the operating system VHD and it's going to install it on a hard disk that's on that physical machine. That virtual hard disk image then gets mounted by your virtual machine, and when the virtual machine boots up, it boots into this VHD. As I said before, this VHD can have Windows Server 2008 on it or Windows Server 2012 on it. When that virtual machine boots up, it will then go and spawn what's called the guest agent. The guest agent is a process that runs on the virtual machine along with your code, and it communicates with the host agent back and forth. And this makes sure that your VM is responding to client requests that are coming in and that it can be reached. So not only is the physical machine, the Azure Fabric Controller, making sure that the physical machine is working fine, but it is also making sure that it's able to reach your guest VM that's running inside the physical machine by way of this guest agent. And now this VM is up and running, the guest agent is here, your code is also in here as well, and then client requests can be directed to this VM, and I'll talk more about how that happens a little bit shortly. Let's talk about the guest VMs that are used for the virtual machine service. Well, for the virtual machine service, as I said before, you at your desktop go and create a virtual hard drive, and you can install whatever operating system you want on there. And you install whatever other components you want on there and your application code and so on. Then you take that virtual hard drive and you load it or upload it into a Windows Azure storage account, into a thing which is called a page blob. Now, when your virtual machine boots up here, it needs to be able to go access the contents of this VHD, which is really on a different machine somewhere in the Windows Azure data center, and it has to be able to mount it here so that it can boot into the virtual hard drive that you've uploaded. Well, the way that they do that is inside the physical machine, they have a special device driver. That device driver catches I/O requests from this virtual machine image and maps those I/O requests into network requests to go to this other service running in the Azure data center to read and write bytes out of this page blob VHD file. But within the VM, it looks like the VHD has been mounted here. Now, of course, every time you do an I/O operation, if that resulted in network I/O, then that is going to generate, bad performance for your application. So in order to improve the performance on the physical machine itself, they do some caching over here so that if the code in the virtual machine is trying to get the same bytes from the same sectors over and over again, they can simply be delivered in a high performance way right off of the hard disk that's inside the virtual machine into the VM. And therefore, only occasionally will some information not be in the cache, and then it will have to make network calls out to the storage account to get that data to bring it back into the VM. Now, I'm going to focus on the platform as a service architecture because that's the one that affects software developers more. Building Windows Azure Cloud Services is really all about building highly available and scalable applications, and this is what you pay for. If you wanted to build a website and just have it hosted somewhere, there's a lot of companies out there that will do that for you, and many of them can do it cheaper than Windows Azure Cloud Services will do it for you. Although, again, Windows Azure does have a simple websites service which is now free for people. So really what Azure is all about, the cloud services, is about high availability and scalability. If these features are important to your company, then this is really what you're paying for. And this is really useful for people who are building mission critical software. We have a service and it accepts customer orders. And if our service goes down for any period of time, then that results in lost revenue. And we don't want to have that happen. So in those scenarios, the Windows Azure Cloud Service is a great choice. If you're a small company and you just have a website that maybe just says, here's our address and here's our phone number and here's how to contact us. And if your website went down for a day or two, then maybe the world doesn't come to an end. And using the Windows Azure Cloud Service feature is probably overkill for you in order to do that. And you'd probably be paying more money for it than you would somewhere else. So it's really about high availability and scalability. Scalability meaning, of course, that with Windows Azure Cloud Service, you have the ability to create a service where maybe you handle, 1,000 client requests a day, but if you need to handle 10,000 client requests a day, you can basically flip a switch and all of a sudden more virtual machines will be provisioned in the data center to go and handle the load that's coming in. And with the cloud service, you are paying for what you use on an hourly basis. In fact, there are a lot of companies who scale up to many machines during the daylight hours, and then they scale down in the evening hours just to conserve money. And Azure can scale up and scale down usually within just a few minutes. So it's actually a very viable model, and it's a good cost-effective way to run your service. But because of this model, it does require that you take into account some application design considerations. Because of high availability, what that really means is that when a piece of hardware fails in the data center, Windows Azure will move your application to another PC. That's great that it will detect that automatically and do that for you, but what about any data or state that you have on that virtual machine? Well, if the machine dies because of a hardware failure, then certainly the state and data is completely lost. So the philosophy of Windows Azure is that you have to build your application to be stateless. You have to take your data, your state, and you have to get that off of the PC. So in case the PC fails for some reason, the data or the state is recoverable in some way. Now let's talk about scalability. What scalability means is that when your load increases, you then maybe provision multiple PCs or virtual machines in order to handle all the client requests that are coming in. But what that means is that some user who makes a request against your service might get load balanced to a particular virtual machine, and then later, let's say they're adding items to a shopping cart, and then later when they want to go and check out, they might get load balanced to a different machine to do the checkout process, because the load balancer effectively picks machines randomly. So in order for that to work correctly, that's another reason why your state has to be off of the physical machines themselves and be stored in a central repository where it's available by all the virtual machines that are running inside the data center. So in order to get high availability and scalability, an important concept is that the data has to reside off of the machines themselves into a central location. So cloud service applications, they require a stateless design. This is really important when building a cloud service app. And so then you might say, well, if I take my data and I put it somewhere else, that's fine here, but what is to prevent the machines where I put the data from those failing? And then I wouldn't have access to my data. Or what if the hard drive fails? Well, in order to solve that problem, the data needs to be replicated for high availability and for scalability too. So in other words, we need a data service where you can put your data in. That data service can replicate your data multiple times. So if one of the hard drives fails, there's other replicas to get the data from. And by having a scaled out service, if any of those hardware machines fail, other machines are capable of processing the incoming requests into it. And so we need this data service that's also available that we can leverage with our cloud service so that everything truly is highly available and scalable. Now, these are some of the main benefits of building things this way, but cloud services provide many other benefits too. As I mentioned earlier, when you use Windows Azure Cloud Services, that automatically, by default, you are opted into operating system and component upgrades. So whenever there's a new version of the operating system or bug fixes, they will automatically be applied to your virtual machine. Windows Azure Cloud Service also offers a diagnostic monitor. It's another application that can run on your virtual machine with you, and it's capable of accumulating diagnostic information, such as performance counters, event log entries, or other log files that might be being created on the machine. It can then periodically take that information and upload that into the data storage service, where you can later go and download this information and then analyze it to see what's happening in your service. Another feature of the cloud service is application lifetime monitoring. Because of that host agent that I mentioned, or I'm sorry, the guest agent that I mentioned on the previous slide, well, that guest agent can monitor your application. And if your application, let's say, crashes because it throws an unhandled exception, it will detect that automatically and it can restart your application automatically. That doesn't happen when you use the virtual machine service. With the virtual machine Azure service, if your application gets an unhandled section and terminates, then it just sits there. You have a virtual machine sitting in the cloud that isn't capable of responding to client requests because your application is no longer running. Now, you could, of course, always create your own watchdog process, if you will, that sits on that machine, and then it detects when the process dies and restarts it. But you get this built in automatically when you're using Windows Azure Cloud Services. Windows Azure Cloud Services also offers a way of automatically configuring firewalls for you, configuring certificate stores on the machine. So if you have any certificates that are typically used for HTTPS, SSL communication, then an IT person in your company can upload those certificates into the Windows Azure portal. And then Windows Azure Cloud Services, when it provisions your virtual machine, will automatically go to the portal, grab the certificates, and install them on the virtual machine certificate store for you automatically. This means that the software developers and people who are managing the physical machines or the virtual machines themselves don't ever have to have direct access to the certificate. Some IT person uploads a certificate into the portal, and then Azure automatically deploys those certificates into the certificate store. Again, with the virtual machine service, you would have to put those certificates into the VHD yourself before you upload it into Azure so that those certificates were there. And if those certificates expire or need change, then you'll have to modify that on the VHD and upload it yourself. Cloud services provide other benefits too, like caching, as I mentioned here, where there is a caching technology that you can optionally install on your virtual machine with you, and it's a distributed in-memory cache that's available. It's included with the cost. There's no additional cost for it, and if your application wants to take advantage of this caching, you basically just turn this on. There's some DLLs that are on the machine with some functions that you can call, and you can put data in the cache, and it can be distributed across multiple virtual machines that are running as part of your cloud service. And there's a bunch of other services too, but this is enough to get you started. Now, this slide here kind of shows the overall lay of the land, if you will, in terms of how to think about the Windows Azure platform services. Let's start in the top left. So here we have people on the globe, and they want to make some internet requests to your code. So those requests can optionally be directed to what's called the Windows Azure Traffic Manager. The main purpose of the Windows Azure Traffic Manager is to take an incoming client request and to determine which service, which data center to send it to. There are some other uses of the Traffic Manager as well. For example, you could have, let's say, version 1 and version 2 of your service running in the same data center, and you want the Traffic Manager to, let's say, send 10% of the incoming requests to version 2 and 90% to version 1. And this gives you a way of doing A/B testing inside the data center. Another reason to use the Traffic Manager is you might have your code set up in the United States and also in Europe and also in Asia somewhere. And when a client request comes in, the Traffic Manager can direct the incoming traffic to the data center that is closest to the customer, thereby giving them reduced latency and improving the performance of your service responding to that customer request. The Traffic Manager is an optional service. You can turn it on, and basically you just configure it with a web portal to give it the rules that you want it to follow and what URLs, based on the rules, it should direct traffic to. The Traffic Manager will ultimately send incoming customer traffic to a data center, one of the 8 Windows Azure data centers. And the first thing the traffic hits when it reaches a data center is a load balancer. The purpose of the load balancer is to take the incoming client requests and to distribute them equally across your virtual machines that are running your code. Now in this slide here, I show 2 virtual machines. There's one rectangle behind another rectangle. That represents 2 virtual machines that are running in your cloud service over here. And I again mentioned on the slide that you need to think of these as being stateless. You want to keep your state off of these machines because the Azure philosophy is that these virtual machines can come and go. It could be a hardware failure and everything just stops. Then they'll just create a new virtual machine out on another physical machine for you. Or periodically, Azure will, usually about twice a month, bring your virtual machine down in order to upgrade it, like with a new operating system or bug fixes, and then bring your virtual machine back up. So throughout the month, your virtual machine could go up and down. So that's a very important concept, is to realize that the Azure philosophy is that these virtual machines, they come up, they go down at any time. You may or may not get notice. And you have to architect your application in order to be able to be resilient against that. So here I show just 2 virtual machines. They're running your application code in both of them. So these VMs are basically cookie cutter copies of each other. And the load balancer just directs traffic to whichever one it wants to at any given time. And then you just execute whatever code you need to execute on those VMs. Now, of course, many services are going to have storage needs. There's going to be some state, there's going to be some data that you need to persist. Certainly, if your customers are making orders, you want to have a customer database where you have your set of customers. You want to keep a record of all the orders. You want to keep a record of what they put in their shopping cart, all of that information. So if the cloud services themselves are supposed to be stateless, then where should you put this state? Well, I mentioned that Windows Azure has a data storage service, which is separate from the cloud service, which is separate from the Traffic Manager service. The data storage service offers 3 different abstractions for data. There's blobs, there's tables, and queues. Blobs, it stands for binary large objects. Think files, if you will. Blob storage is where you would put, well, files. It's like PDF files, Word doc files, PowerPoint files, images, music files, videos. That's the kind of information that you would put into blob storage. And everything in data storage here is replicated 3 times, by the way, and this is a storage service. So when your cloud service wants to talk to the data storage service, that is making a network request. But usually it's a network request that's within the same data center. And within the same data center, the network cables are a very fat pipe. And so the bandwidth is very high and performance tends to be very good. In addition to blobs, the data storage service has table support. This is like a NoSQL kind of non-relational table support here. And this table support is perfect for things like your users, your customers at your company, the orders that they've placed. It is perfectly suited for that kind of stuff. And then we also have in data storage service queues. Queues are typically used as a way of communicating some workflow from one of your machines to another one of your machines as part of your data service. For example, you might have some front-end web servers that process incoming client requests as users are looking at your inventory of the products that you sell and they're adding items into their shopping cart. And then once the user goes and checks out and they place the order, then there's a bunch of work that has to be done in order to actually place the order. So you might put a message into a queue that could be pulled out by another service, that message, and then that would start the workflow of doing the order processing on behalf of that user. Now, in addition to the Windows Azure Data Storage Service, there's also Windows Azure SQL Database Service. This is a different service, which again would have its own different way of authenticating, its own service level agreement, and its own way of authenticating with the service. And this is very similar to SQL Server, but running in the cloud, in a Microsoft data center. And you create databases here, and unlike tables, these are relational databases or relational tables. So you can have, lots of different tables with relationships between them, and you can perform transaction operations when you are inserting items and removing items out of the databases that you create into here. These databases, by the way, are also replicated 3 times as well. And of course, you can back them up into on-premises resources too. Now, those for data storage. Windows Azure offers some other services too, like the Active Directory service, which is an identity mechanism which your application can take advantage of to allow people to use it in order to log in and authenticate with your cloud service. There's the Service Bus service, which actually has a lot of similarity with the queue service as well. But it has a different way of authenticating with it, and the Service Bus is typically used for applications that want to communicate with hardware devices that are outside of the data center. For example, if you wanted to build like a phone application that was an instant messenger application, and then each user would type in some message they want and then hit send to send it to the other people that they're part of the conversation. Windows Azure Queues could be used for that, but Service Bus is really a better choice for that. It has a different authentication mechanism, and it's a better choice for establishing it on the phone device itself and for sending the communication up into the cloud. Windows Azure also has another service called the Shared Caching Service. This is a service that Microsoft introduced, but due to the high price of it and latency issues with it, never really took off very well. However, Microsoft has now countered that. They have created a caching technology that you can turn on and enable on your cloud service virtual machines. And this other caching technology is free. It comes with the cost of your virtual machines. Whereas this shared caching is a service that you had to pay extra money for, and it had different authentication and so on. So it was really difficult to use and it was very expensive. But leveraging the caching technology on your machines, that's very inexpensive. As I say, it's free. There's no special authentication because it's within your services, so it's much easier to set up. Because it's on the same machines, it actually runs faster, and it's the clear winner in terms of cache technologies. I also mentioned that Windows Azure has some networking services like the Virtual Network Service and the Windows Azure Connect service. And the idea with these networking services is they allow the virtual machines that are running in the data center to communicate with machines that you might have on premises. One example of use for this is that your company might have a bunch of its users stored in an Oracle database. Well, you'll notice over here there is no equivalent of an Oracle database that's running in a Windows Azure data center. They have a SQL database, but not an Oracle database. So you might want to have your Oracle database reside on premises, and then you might want to have the customers go and hit your website that's running in a Windows Azure data center. And then when they put in their username and password, your website code could go and communicate with the machine that's on premises that has the Oracle database on it, do the authentication, get a token back, and then start using that token in the cloud service over here. Of course, there's going to be high latency when communicating from the cloud service to your on-premises machine. The amount of latency, of course, depends on many factors, like what else is happening on the internet and the bandwidth that you have into your company and how physically far apart your on-premises machine is from the data center. So just be aware that the latency could potentially be quite high. But if you're just doing it for authentication, users kind of expect that when they log in, there's going to be a performance hit. But then after that, you can continue to run things at a very high speed. Of course, networking can be used for other scenarios too. Sometimes it's not because there's no equivalent in the cloud for an Oracle database. Sometimes people want to keep resources on premises because it contains security conscious information. Like you may not want to take your customers with their phone numbers and their addresses and maybe social security numbers and store that into a Microsoft data center. You might just feel more comfortable having that in your on-premises data center. But your actual code for your service is fine to put it up here and to have this scale out, and then you would use the networking component in order to communicate between the two. I should mention, though, that while cloud services do not support an Oracle database, and these other services that are Azure services, Microsoft has no equivalent of an Oracle database. You could create inside Windows Azure a Windows Azure virtual machine service. You could use the virtual machine service, and in there you could host Oracle database or even your own SQL Server database. You could host in there as well. And so some pieces of your service could be cloud service and other pieces of it could be using the virtual machines. Again, this allows for these hybrid apps where you can mix and match all these various things in order to architect and design your overall service the way that really seems to work best for you. Pieces of it can be in the cloud services, pieces of it can be websites, pieces can be virtual machines, pieces of it can be on premises using the networking component. All of those scenarios fully function. And of course, there's nothing stopping you from using third parties. If you want to use, let's say, Amazon's data storage services, you can do that too from your cloud service that's running in Windows Azure. Of course, you'll be going over the public internet then because you won't be in the same data center, and so there will be higher latency and probably higher costs that are associated with that, but it's a very doable thing. The last thing that I'd like to mention here on the slide is the CDN POPs. The CDN stands for Content Delivery Network, and POPs stands for Point of Presence. I mentioned earlier that Windows Azure has 8 data centers around the globe. That is true. But Windows Azure also provides a content delivery network service. And the content delivery network services uses approximately 24 data centers around the globe. The idea here is that you might have in data storage in blobs, let's say some videos. And these videos, you would like to make it available to your customers who may be situated all around the globe. So you might have customers in India, customers in China, customers in the United States, and they might want to go and watch these videos. Well, if you put all of these videos into blob storage in, let's say, a United States data center, then when a customer from India wants to go and watch that video, they're making network requests halfway around the globe to reach your data center, the data center in the US, so that it can start serving that video content out. That means your customers in India would be experiencing very high latency, in accessing the video, and it might not stream very smoothly, so it would be a jittery experience for them. The idea behind the Content Delivery Network, this is an optional Windows Azure service that you can turn on, and then of course there's additional billing associated with it. But when you do that, when the client makes a request to watch a video, the request gets directed to one of those 24 point of presence data centers that's closest to the actual user. That point of presence data center will then go to the point of origin data center to get the video and download it. So there will be high latency there and whatnot, but the video will be downloaded from the point of origin data center into the point of presence data center. The point of presence data center will then cache that video. So as other client requests, let's say from India, want to go and watch that video, it will be served from the data center that's closest to them, meaning reduced latency and smooth streaming of the video. Now, whenever the point of presence data center downloads something from the data storage, the point of origin, that data has a time to live on it, and you get to specify that yourself. And when the next request comes on to the Content Delivery Network point of presence, and if the time to live has expired, it will go back to the point of origin to see if the data has changed. If it has changed, then it will download the new version of the data and start serving that up to the customers. If, on the other hand, the data has not changed at all, then it will serve what it currently has and just keep serving that. So it won't have to download it again if the content hasn't changed. I also mentioned here that the CDN POPs can direct requests to the load balancer. Web services can return largely static data out, like HTML, that has that can be cached. And if you're returning HTML out of your cloud service, that could be cached on the CDN POP servers, so that client requests that are coming in to maybe get the same kind of information, like the temperature in your area, is something that doesn't change all that frequently, then the CDN POP might be able to return that immediately back to the client without having to go through the load balancer to get to the right data center to make the request of your service and return all of that back. On this last slide here, I just wanted to point out a couple of useful Windows Azure websites. The main Windows Azure website is at windowsazure.com. This is the website that you would go to learn all kinds of things about Windows Azure, such as what the pricing is for the various services, the support models, the service level agreements. There's forums on here where people can ask questions. There's the dashboard where you can see how the service is doing, like are they experiencing any problems inside the data centers now. There's legal information here, frequently asked questions here. There's also a trust center. A lot of times people ask questions about if I put my data up there, then what kind of guarantees does Azure make me, and what kind of security is there around that data? The Trust Center can give you that kind of information. In order to start using Windows Azure, you would go to the Windows Azure Management Portal, which is at this website address here, manage.windowsazure.com, and then you would log in with your Microsoft account ID and provision for yourself an account. And this is where you would go to provision things like cloud services, websites, the virtual machine service, the data service, the Active Directory service, and all of that. This is how you set all that up. You get your credentials here with certificates and usernames and passwords, and all of that is done by way of the portal. The last thing that I'll mention is that Microsoft does provide a bunch of virtual labs. So for people who are just getting started with Windows Azure, you can go to this URL over here and download some virtual labs, and then you can use Visual Studio to build some things, deploy some things, walk you through the management of that, and so on.